Okay, so let's look at number 16 here. We're doing this problem, number 16, from the practice exam number 4, the non-multiple choice part. So this is a hard question. I changed the numbers here a little bit just to do a different example. So let's try working this out. So how do we do this? First thing is we got to draw this. So 90 pounds south, 65 east. So let me draw this. So this is number 16. So what is it? 90 pounds south. Okay, so I'm going to draw it right here. In fact, actually, let me put it over here on the right. So what was it? 90 pounds south, 65 east. £90 south, 65 east. 90 south, 65 east. Okay, so I'm going to draw that. So it'd be about right there. So it's south. See, right? This is north, south, east, west. It's south, but it's not straight south. 65 degrees to the east of south, right? So south, but not straight south, 65 to the east of south. And then the second vector is 100 pounds north, 70 east. So the second one is 100 pounds north, 70 degrees east. So it's north, but not straight north, 70 degrees to the east. 70 degrees to east. And that one is 100-pound force in that direction. All right, so now the first step is to turn both of these into I and J. So how do we do that? Well, we've got to find the actual angles, which means from 0, right? Because this is 0 degrees right here. So then what is this angle? That must be 20 degrees, right? Because 90 minus 70, that must be 20 degrees. And then what is this angle? What's that angle right there? That must be 270, right? Because straight down is 270 plus 65. What's that? 335. 335 degrees. So that one must be 335 degrees to that vector. So the first thing to do is get the actual angles, which means from 0 degrees all the way to the vector. All right, and then we write the vector will be 90 cosine of the actual angle. I'm doing this one first. 335 degrees I plus 90 sine 335 degrees J. Right, so I'm taking the 90 vector and doing him. So then use your calculator on that. Get some numbers there. I'm doing it myself on the calculator. So I'm getting 81.568 I plus 90 sine 335 negative 38.036J. Okay, now let's come on down and do the second vector. So same thing here. It's going to be 100 cosine. What's the actual angle? 20 degrees, right? From 0. 20 degrees I plus 100 sine 20 degrees J. So let's crank that out. I'm getting 93.969 I plus 100 sine 20. I'm getting 34.202 J. Okay, So now, so that's all step 1. Step 2, add the vectors. So step 1 was changing them to ij. Step 2, add the vectors. So I'm going to have to add this and this on my calculator. So 81.568 plus 93.969. I'm getting, what am I getting? 175.537i plus, then add this and this. So one of them's negative, 38.036 plus 34.202. I'm getting negative 3.834j. So that's what we call the resultant vector, the result of those two. Now the third step is to change back. Change back to magnitude of the resultant vector and angle of the resultant vector. So the magnitude of the resultant vector, you know that's square root of the first number squared, 175.537 squared plus negative 3.834 squared. So I'll do that on my calculator. I'm getting 175.58 rounded to 2 places. So that's good. Now the hard part. The hard part is finding this angle theta. So this is the part I found a lot of people are a little confused on, that we want to be super, super clear on. So there's a couple steps, and you really can't skip any of the steps if you want to get this part right. So step number 1, the reference angle, not the actual angle yet, but the reference angle is tan inverse of absolute value, meaning got to make it positive, of b over a. So therefore the reference angle will be tangent inverse. So what's b and a? What's b and a? We mean this is b, the number next to j, and this is a. A and b are next to I and j. So this would be positive 3.834 over positive 175.537. See how I made them positive? These absolute value signs made me make that negative right there into positive. So hit the buttons on your calculator. Take the inverse tangent. I'm doing it right now too. Inverse tangent 3.834 divided by 175.537. I'm getting, oh wait, am I in the wrong mode? No, I'm in the right mode. Okay, so I'm getting an angle that is 1.25 degrees. I'm in degree mode. That's 1.25 degrees. Now, step number 2, you have to draw the vector to find the quadrant. You got to find which quadrant you're in. You can't skip this step. I've noticed a lot of people try to skip this step. You can't skip this step. A lot of people just just think the answer is 1.25. It's not. You got to draw the vector to find the quadrant. What do I mean, draw the vector to find the quadrant? This vector, the resultant. We're talking about where is the resultant vector. The resultant vector is, this is positive and this is negative, right? So it's right and down. It's right and down. So the vector is down there in the 4th quadrant. Let me draw that a little better. The resultant vector is down there in the 4th quadrant. Do you see why? Positive on the I is the sideways, the J is the up and the down, and the J is negative. So it's right 175 and it's down 3.8, isn't it? You see that? It's right and down. So the resultant vector is in the fourth quadrant, isn't it? Okay, so what? What does that mean? Well, let me draw this a little bigger, have a little more room here. We've got to use that. Let me draw it over here. So it's over here. Okay, and then step 3, find actual theta. So now that we know the resultant vector is in the fourth quadrant, this vector here is in the fourth quadrant, we're going to find the actual theta. Now hold on, what's the reference angle? What is a reference? I think a lot of people are not super clear on what a reference angle is. What in the world is a reference angle? It's to the nearest x-axis, to the closest x-axis. Whereas an actual angle is from 0 degrees to the vector. See the difference? An actual angle starts at 0 and goes all the way to the vector, whereas a reference angle is to the closest x-axis. So when we say the reference angle is 1.25 degrees, we mean from here to there is 1.25 degrees, right? That's to the nearest x-axis. From the nearest x-axis to the vector is 1.25 degrees, now that we know it's in the fourth quadrant. Okay, so what? So what's the actual angle? From 0 all the way to there, right? Because this is where 0 degrees starts. From 0 all the way to the vector. From 0 to the vector, that's the actual angle. Or they call it the direction angle. Actual angle, direction angle, same thing. What is it then? Well, it must be 360 minus the 1.25, which equals 358.75 degrees. 358.75 degrees. Is that making sense there? 358.75 degrees is the actual angle on that one.